Welcome back, Matteo Migliorini here. Today I want to answer to another question again on the old tutorial about normals direction. This tutorial is very requested for the questions. So, by the way, someone asked me, can I do the same things with VOP? Here we have the attribute VOP. Inside the attribute VOP you can use the position of the points, because here the attribute VOP essentially it's working on the points. Here is run over the points, so it's not needed the first input to say create the vector by the byte the points, use the point expression. You have the points, and here we have the import points. Inside the import points you can choose, for example, file. You can choose the OP input, the operation input number 2, okay? And here we have the file, and from attribute I have here the signature like vector. By default is float, but I prefer use the vector, the 3D vector, and the attribute is by position. In this way you can say take the attribute from the second input and import inside my VOP. Here I apply the subtract, normalize, and then I have the normals. If I apply, you can see here we have the normals. If I change, for example, from the points, here we have the points, okay, with the scatter. I can show you also with the difference. Yes, you can see it's change the position and change the normals, okay? This is the way. What is maybe the better, you can see inside the VOP, for example, here we have the another things, and also I don't tell you, but for the point number you can use here the point number, you can enable that, and you can use, for example, the constant is number 0. If you have, for example, 2 points and you want number 2, okay, you can say here I create 3 points. I can show you the enum. Okay, I want the number 2 is drive my normals. Okay, when I import here I say number 2. If I say 1, obviously there should be enable that, okay, that, okay. If I want to remember, this is 1, 2, and 0, 0, 1, and 2, okay. If I want is derived from another, you can say if I change the number of points, it change also the direction by the position of this point. I can show you here the number of points. By the way, you can inside the VOP you can see visually what do you do. For example, you can use also the add, you can use the subtract, you can apply, for example, the switch for see the difference effects of that, and also you can normalize, and then you can also apply like for convert, for example, the normals to velocity. You can apply the multiply with the constant. You can see it's apply your effects. You can say also 10, 5. That it's always visually. You can see in immediately how it's working. It's very linear. And here you can have the export, for example, the value. It's better or not to respect the VEX? Depends. If you are more confident with the VEX, or if you are more confident with the VOP, you can use or VOP or VEX. Essentially, it's the same. VOP is the system for see visual code operation, so you can see visually what you do. VEX essentially is the string, is the code. You can see only the code, you can refresh. In sometimes it's better the VEX, because I prefer use the VEX because maybe it's more faster for me, but that it's how your workflow and how much you are confident with this system or another system. Okay, if you like my video, please subscribe because it's more important to grow in this channel, and for me, for you is the free, so follow me if you like it, and see you soon. Bye.